Whatever the programming language you use, you know it is not possible to build a complex application with just a monolithic single UI. In large applications, we need to break the user interface into smaller, manageable UI abstractions. These UI abstractions should have a clear and defined interface for the rest of the application to interact with them. We commonly call these manageable abstractions as UI components. Your application may easily end up having dozens of UI components such as menus, the tree components, localization components, and theme selection components, etc. For you to make your code base maintainable, these components should not be tightly coupled to each other, but they need to be self-contained. When I say self-contained, that means any of these components may be added, deleted, or even moved with absolute minimal changes to the rest of the application. In addition, let's say you want to change something in this menu component. You should not be dangling around the whole application code base to see what else needs to be changed to make things work as before. Instead, you just go into the menu component direct and do the change and be comfortable that nothing is broken. Now let's get into see some UI component recommendations from BoilerplateJS. If you look at this component which is used to manage departments in my sample application, you will notice it has its structure which is defined by HTML, and it has its presentation which is defined by CSS as well as images. And also it has its behavior defined by some JavaScript logic. In addition to these, my component can respond to the localization changes as well. If I go and change my language to Swedish from English, you will notice a text change on my UI component. Let's have a look at the code of this UI component. In BoilerplateJS, you will have to go into the source folder, and inside source folder you will need to select the particular module in which you have your UI component. In this case, I know my department's UI component is in sample module 1. For the viewing purposes, I'll get into the department folder so that the files we can view clearly. As we discussed before, BoilerplateJS architecture encourages you to have your parts of your UI component in a single folder. When you view a folder of a particular UI component, one of the most important files you have here is your view.html. View.html defines the HTML template which defines the structure of your UI component. When you open that file, one of the things you will notice is these tags. These are the placeholder tags for localized resources. BoilerplateJS uses require.js i18n plugin in order to manage and define the localized resources. The NLS folder contains resources which are of different locales. For an example, the SV folder is for Swedish locale. If you look a bit deep into the HTML template, you will notice some of the HTML elements having a custom attribute called databind. Most of the UI components in boilerplate sample code uses knockout.js to implement MVVM pattern. For example, you will notice this button has a binding to a click event called remove selected bound to it. This remove selected is defined as a method in the viewModel.js file. When the button is clicked, knockout.js ensures the remove selected method is invoked to handle the button click event. But one important thing to note here is that Knockout.js is not something enforced by BoilerplateJS architecture. You may use any other MVC MVVM library such as Backbone or Kendo MVVM for binding your view to your behavioral logic. Now let's have a look at the component styling. In case your component needs some specific styling to be done, you may use your own CSS file within the UI component. This CSS file may also have its own assets such as images or videos with relative positioning. For an example, the assets department.jpg file, you can find it inside the assets folder. Even though having custom CSS files for each and every component looks elegant, we recommend minimizing component specific CSS files for two reasons. First of all, when you have application theming, having your CSS scattered across multiple files makes theming quite difficult, if not impossible. The other reason is about performance. Having too many small CSS files can make your application load time to suffer. One other thing to note here is these custom CSS files are not aggregated by the BoilerplateJS optimizer as of now. So more files meaning lesser performance in loading. But there are certain instances you might need to use custom CSS files within your UI component. One of the common example is with third-party libraries. When you have some third-party controls, you may need to use some CSS hacks to get things working properly. Now we have looked at all the parts of our UI component other than one most important file, which is the component.js. Component.js does the assembly of all the subparts which we discussed before. When you open the component.js file, you will notice some dependency imports on top of it. Here the view template, the view model, locale resources, as well as the CSS file are imported as dependencies and being used within the component class. The component class mainly consists of two methods, activate and deactivate. These are the interface methods expected by the front controllers of BoilerplateJS. Front controllers are the controller classes that decides when to activate or deactivate your UI component. In BoilerplateJS, there are two main front controller classes. One responding to URL changes on the browser, which is called the URL controller, and the other one responding to DOM elements, which is unsurprisingly called DOM controller. We will discuss how these controllers work in detail in a later video. But for the scope of this video, what is more important is to understand how your UI component may react to the activate and deactivate calls coming from these front controllers. The code inside your component class is not that difficult to understand. If you look at the activate method, what it does is when you get an activation call, it will actually check if the component is already created, if the panel is existing. If it is not existing, it will create the panel, attach the style sheets, and create the view model, and it will use knockout to do the bindings. As we discussed before, you can use any other technology other than knockout as your preference. And once the panel is created, You will initialize your view model with whatever the parameters you are getting from the controllers. Once a view model is initiated, then you just show the panel to the users. Under deactivate method, it's a simple if statement to check if the panel is existing, and if the panel is existing, we will just hide the panel. So the activation deactivation, what it does is basically to create the panel and show and hide it. There's one important thing about show and hide. Instead of doing show and hide, we could have even created and deleted the DOM element every time users activate and deactivate. But the issue here is, even though you delete DOM elements from the parent DOM, they don't really get garbage collected. They just reside in the browser. That means if you create your component multiple times and delete it multiple times, it's going to consume quite a lot of memory as well as CPU resources. So as a best practice, always try to reuse your components and show and hide them. The next thing which is important to understand is about the state of your application. It is a very good practice that you create your application to be stateless as much as possible. You keep your state always in the on the server, backend server, meaning the backend server act as the single global truth about the state of your application, which makes your life easy when you have so many clients connecting and querying about state information from the server, as well as that makes your application very scalable as well.